Okay, the examples we saw before all had nice square roots, but what if the square roots aren't in the nice form where it's a sum or difference of two squares? Well, if that happens, what we have to do is complete the square before we can do the substitution. So let's look at this thing. We've got x squared plus 2x plus 26. Um, that can't be factored, but what we can do is write it like this. I take it to x squared plus 2x plus blank plus 26 plus blank. All right, so what I want to do is I want to figure out what can we put in this blank here to make this part over here a perfect square. And well, if I take 2, I'm going to divide that by 2 and then square it. So we get 1. So I'm going to put that there, and then I'm going to put a 1 over here in this blank too. And actually, I'm going to make this a minus instead of a plus. And then we're going to split this into this and that. Now we've got a perfect square over here, so this is going to be x plus 1 squared. Then plus 26 minus 1 is 5. So we can rewrite our integral over here as square root of 1 over, or I'm sorry, integral of 1 over square root of x plus 1 squared plus 25. And now we can do trig substitution. What we've got here is our, let's see, u in this case is x plus 1, a in this case is 5. So the substitution we want to do is x plus 1 is equal to 5 tan theta. All right, and from here on out, it's just like the other problems. So let's see. Differential of this is going to be, well, the derivative of x plus 1 is just 1. So you get 1 dx. Derivative of 5 tan theta is 5 secant squared theta, d theta. And then the stuff under the radical is going to be, let's see, x plus 1 squared. So that's going to be this thing squared, so 25 tan squared theta. Plus 25. So you can factor that 25 out, and when you bring it outside the radical, you get 5. Then you've got tan squared theta plus 1. Of course, tan squared theta plus 1 turns into secant squared theta. Then take the square root, you get 5 secant theta. So my integral turns into, let's see, on top I've just got a 1, but I'm going to go ahead and put the dx on top. So dx is going to be 5 secant squared theta d theta. And on the bottom, we've got the radical, which turns into 5 secant theta. So this is actually turning into a really nice problem, because the 5's cancel, the secants cancel, and we're just left with the integral of secant theta d theta. All right, so what can we do with this? Well, we just need to use the formula for secant. The integral of secant is natural log of secant theta plus tan theta. It's a lot like a previous example we did, except in this case, we've got the tan right off. Let's see, tan theta is x plus 1 over 5. So that's opposite over adjacent. And that makes this side over here the square root of x plus 1 squared plus 5 squared. So that's going to be x squared plus 2x plus 26. which again is exactly the thing we started with. All right, so we've got tan. Let's see, what is secant? Secant is hypotenuse over, let's see, it's reciprocal of cosine, so it's hypotenuse over adjacent. So our answer is ln of secant is this plus tan plus c. And then we can use logarithm rules to eliminate that 5. So we've just got natural log of absolute value of x squared plus 2x plus 26, then plus x plus 1 plus c. And that's our answer.